How's it going, everyone? Let Gonzalez here again, and in today's video we're gonna take a look at how can we now build a build and test automation process using this CI/CD approach, which is from GitHub Actions. How can we now make use one of their process on their computers, on their servers, as a way to run this particular automation test, which is, hey, our application works as expected. Are we running the test and all of the tests pass? And if it is, all right, can we deploy this code to production or to any staging environment? Okay, so we can make, for example, some of this review process before deploying our code to production. So this is one of the things that we are going to look in today's video. This is a course taught by Steve Kinney, head front-end engineer at Temporal. And well, one of the goal of this course is to see how can you now maintain large code bases over a long period of time with a wide range of contributors in large teams. So because of that, this course is now outlined, or it's structured in this particular way, where we're going to see how can we build our infrastructure to make that happen. So for that, we went through understanding what is maintainability in terms of software, in terms of UI development, and that is, well, that we need to have the ability to add code and change it, update dependency, and also migrate to new frameworks, for example. And the reason for that is because most of the time you're going to inherit some old code bases that needs to do that, or perhaps the product direction changed. The CEO wants to implement some other features or implement a particular POC, proof of concept. Perhaps you want to migrate to whatever framework is hot in these days, or you might need to start a new project from the scratch with the right foot. So because of that, these components to actually guarantee this is that you need to have a build system. Okay, you also need to have a testing. You need to have a static analysis of your code using TypeScript, something that we're gonna see that. You need to separate the concern, especially if you're developing user interface. So this is the business logic and the UI logic, as well as a deployment process. How you're going to deploy your code is that if your code is going to be ever use CDNs, content delivery networks, and also a design process. How are you going to deploy your code? How are you going to add new features or change it? What is the particular process on that? This is all of the components of, according to Steve Kinney, a well-architectured UI app, right? So because of that, we also look at the ingredients to make these applications sustainable, maintainable. That we need to define as a systems that aims to that particular goal, which is the maintainability or sustainability. And this is the system that we need to have in place in our code base, the testing, the build systems, as well as the static analysis, so we can then move on based on our pyramid of needs. And that is, what are the process once we already have all of this system in place, this infrastructure, this basic operations or these basic installations to guarantee it is operations, in this case the maintainability for this economy, for this judicious use of resource. Okay, so when we have that in place, this infrastructure, which is, we're gonna make a quick pause here, is like what are the basic things that you need, for example, to hit the gym, or to no, sorry. What are the basic system that you need to have in place as a way to be fit? Okay, well, that you need to not only go to the gym regularly, take a good sleep, eat healthy, and then you manifest that, as you can see here, right? And then you want to know is like, okay, what are the process that once we define this system, this basic installations, this infrastructure, okay, which is, hey, we know that this is we need a eating system, we need a sleep system, as well as a activity system, right? Just to mention a couple of this. And then you're going to ask yourself, is that how are you going to do that? So for example, how you going to do now is develop this eating system. It's like, hey, you're gonna eat once or two per day, or 3 times per day, depending on your goal. All right. What are the nutrients? What are the food that you need to eat for that? Oh, well, that I want to eat is something that is good, tasty, nutritious. How often you want to do that? In my particular case, I just eat only once. Okay. In that one meal, I just take roughly 4K calories, 4,000 kilocalories. That is a spare, that is. That is spare across protein, so poultry, chicken breast specifically. So chicken breast, salad that contains carrot, onions, lettuce, cabbage, 200 roughly of each one of them, 200 grams of each one of them, a little bit of oil, olive oil, all right. Also, interesting. I grate. Really? Great. Interesting. Great cheese. Grating. Great.
Great cheese.
Great. Grating.
Grating cheese.
Grating cheese. Interesting. This is the first time I hear about this verb. Oh my god. Well, grating cheese, or I grate cheese. I grate cheese. I grate Parmesan cheese over these salads, as well as I ate 100 grams of peanuts and sunflower seeds. I also take water. Sometimes I combine that with cambur or bananas. Also with blueberries, 100 grams of blueberry. But the whole point of this is that this is the process. This is my process as a way to guarantee that particular goal, which is I want to be fit. Okay. And similarly with the sleeping habit, it's like, hey, I need to sleep in this particular hours. Okay. And also, well, this is something that I need to actually fit that way much more. And what'll be my exercise routine? What are the routines that are going to focus? I'm going to do push and pull, and how I'm going to organize that as a way I can do that in the most fast way possible, so I don't have to spend like 2 or 3 hours at the gym. It's like be very efficient and effective in that. So Yeah, that's something quite interesting because by describing this as well as the process, now there are certain patterns or recurring problems that's going to happen over and over and over and over and over and over and over. So, for example, is like in the case of food, is how are you going to now restock? You know, this is a recurring problem that happens. How are you going to restock yourself? How are you going to sometimes you're not going to sleep better, or you're not going to have a 100% sleep, but what are the things that you need to do to achieve that? And this is just to mention some of these particularly recurring problems that happen, right? What will happen if you can hit the gym today, okay? For example, or what happened if you do, but it is raining, okay? All of these particularly patterns that you're going to solve that once you do that. Pretty much here the same as the development. So, as I mentioned before, this is the system that we need to aim the goal of maintainability. Okay, so anytime we have a particular goal in mind, in this case maintainability, we need to define the systems. The less, the better. Okay, as well as the process, and well as some of the patterns that are going to happen. So in the case of the process is that, okay, once we define this base systems, what are the know-how, the step-by-step of doing this kind of thing? So for example, code review, or design process, the blueprints, as well as the document design. And when we encounter is recurring problems, when we need to define is these systems, all right? So for example, hey, how can we now organize our project in a way that we can actually how can we organize our project based on the architecture? How can we organize our projects based on testing, okay, or based on the build systems, or based on the static analysis, the architecture. Another way is that because we are working with UI, okay, how can we organize that state for that? Which is, well, looking at the flux pattern. So you get the idea. And also is that how can we now, for example, organize our code in a way that make it much more easy to manage and maintain abstractions. So you have models and that kind of thing. So this is just to be able to describe that any time that we encounter a particularly that we need a goal, that we need to set a goal, there's some systems in place that we need to define, some process, and then some pattern. This is based on this diagram and the pyramid of the Maslow pyramid. And I think this is something interesting because the whole point of this is based on outcomes. That's all. So we are doing all of this is for outcomes, not for hard work, not for because things look nice. No, for outcomes. So because of those outcomes, first we'll look at how can we write our tests, to define the test systems. In there we need to define some sort of a concept, unit, components, unit integration testing, and E2E. We're not going to dive deep into that, as well as some of the concepts, especially when you're writing your unit test, which is what we are going to focus here. How to run unit tests, first how you set up the V-test, how you set up your infrastructure, and then how you write your tests, some advanced techniques to write tests, and then go into our first foray into set up a build system that that run the aforementioned test to see everything work as expected. So this is now a more hand-practical approach of what we're going to do here. But the idea here is to understand why we're doing the thing that we do. And in today's video, we're going to focus is on creating these GitHub actions. But before that, briefly describing is this unit testing concept, assertion, test, and test suite. Walk through what we have done so far, which is looking at how can we create our first test using vtest. What are the things that it allows to do? How can we start to write our test with it and test, and how can we check that actually a particular function, which is the whole goal of unit testing, do what it's supposed to do by using is the to be. That it checking is referential equality, which means is that, hey, is this two objects has the same reference in memory, and the other is value equality. Hey, is these two objects, their list of property and values are the same? Good. And then the greatest hits for that, or the greatest hits when you're going to write your test. So you have now the to be close for floating points, or the to be instance to actually take a look at if the proto of this object has a reference along the prototype change to that function construction. Okay. As well as the to contain, is that, hey, is this element actually contained or is in this collections, the contain, to throw error, useful for checking if a function actually do what it's supposed to do. If it's not, check that, throw that error properly. So to throw an error, to match for checking strings, to match object for objects, expect any for checking the type, not the value, as well as some of the other convenient things that is array containing, okay, spec array containing, or spec array or spec object contain. This is useful when you only want to care about is a small set of property that exists in these objects. Very, very useful. So we'll look at that example here. That right? It's not that hard. It's actually pretty straightforward. The TLDR of this, especially when we're writing our test, is to look at what are the discipline or the pattern to write this test. We define the initializations, then this testing logic, and then your assertions, and make everything in one place. So put all of this code at a glance for readability. So you can now do not need to actually spend a lot of time to actually see where is this coming, where is all of this. So this is the discipline that provide this unit testing. And the discipline here is something important to take in consideration, because that actually is what allows to achieve a particular goal. So the discipline not only for artists, or athletes, or if you want to have a fit body, or you want to progress in your profession, in this case, if you want to understand more about unit testing and build things, that the discipline is something that will give you is the understanding and the outcomes that you want. So we also look at some of the tips here, especially by looking at this advanced pattern when you're writing your tests with asynchronous. So for example, you have now async and await. Another technique is that you can now is the reject or expect, useful for handling. Is reject most of the time is useful for promise or reject, as a way to check that actually get the error that we want. Some of the tips, for example, when we are looking at bug report, is that, hey, take that bug report, take the problematic code, write a failing test that passes. Okay, so write a failing test to make it pass. So this is one way of how you can guarantee is that this bugs prevent any bug regressions. And the other is that when you need to handle is DOM operations that or timers in DOM operations or any elements that is going to appear in the DOM and then disappear, you can use now the set timeout for that, as well as the date now. So the idea here is accelerate the time that happened. So this is quite interesting, very, very interesting. Something that you're gonna see a lot when you are writing your component testing, right? To check if this element actually appeared as it's supposed to be, and so on and so forth. All right, so now what we really care about in today's video is how we're gonna build this CI/CD pipelines. Okay, this GitHub actions. And it's important to describe what this is all about, as well as the anatomy of this. Okay, similar that we described the anatomy of the unit testing, all right, as well as the anatomy of the testing system. Where now here we're going to look is at the anatomy of the build systems. In this case, using GitHub actions. Following is this CI/CD process, which is a practice of how you can now automate is your build, test, and deployment process. Okay, so this is useful for large companies where there is a lot of people contributing to the code base. And the idea of today's video or the thing that we're gonna do here is to see how we're going to implement a CI/CD, the testing, the build, as well as generate cover report and saving playwrights video as well. That's quite interesting. But first things first, we look at the build systems anatomy, and that is usually made by the continuous integration, continuous delivery. You also have the continuous deployment as a way to automate the entire process. But depending on the type of application that you have, you usually, for example, healthcare or defense or hardware or any of this specific industry, they want is you to now have a human review process. So pretty much like the training of LM, when they have this reinforced learning with human feedback. The whole point of this is that, hey, there must be a human here to actually guarantee that this is what we expect. So this anatomy here, okay, pretty much like anatomy here. Yep, like the anatomy here. That's not. Again, that's what we want, man. That's what we want. I didn't set the rules, and I'm not going to fight against that. I didn't set the rule, and I'm not going to fight against that. Not at all. You want to do that? Good for you. Good for you. You truly want to do that? Good for you. That's what it is. Wait, what? Oh. Really? Oh. I'm not surprised, bro. No. Okay, it's like Good, good, good. So yeah, similar to that kind of anatomy, all right. Yes, similar to that kind of anatomy, like this. Wait, what? It's like you're watching porn. So yeah, similar to that kind of curve or anatomy, like that. Yeah, that's what you need to employ your. That's what you need to employ your one. Like, yeah, it is what it is. It is what it is. It is what it is, man. And the funny thing is that everybody can do that, man. Everybody can do that, man. Everybody can do that. So that's interesting. No. But you get the idea. You get the idea. You get the idea. So because of that, right? Similar to this anatomy, you have the unit testing, and now the anatomy, the unit testing and the testing system. All right, that you need to define is the set of environment, as well as the unit testing that you want to build, right? We're going to then later on see how can we do this integration in this E2E as a way to make sense of what we're doing here. And the other is, well, right now is looking at the anatomy of the CI/CD process. Okay, when you have the continuous integrations, continuous delivery, and continuous deployment. So right now we're going to focus on continuous integrations and continuous delivery, and that is on the continuous integration. We have the build, the test, and the artifact that is going to be generated, okay? And on the continuous delivery, we're going to check that artifact by putting on a staging environment to see that everything works as expected before production, okay? So, because this is the anatomy, okay, of this, which is plan, code, build, test, and artifact. At least this is one of these particular process of this build system. All right, is that hey, you're going to plan what you're going to do, you're going to implement that, you're going to now build, pass through the continuous integration, build the code, everything works as expected, test that, generate an artifact, which is a version of this application that is be passed through a staging environment to see that everything works as expected with data close to productions, and then you deploy that to productions. Again, all of this says easy to do that, right? Because once you deploy that code, you need to operate in monitoring that. So you need to say, it's like, hey, everything worked as expected. And if it is, let me actually monitoring that. So yeah, this is now describing is what is the end role of all of this, or at least the role of all of this. The goal of all of these roles, the UI engineering, the backends, and the DevOps, and the whole point of all of this is to understand what is the intersection of all of this, which is automation. Period. That's the value that we are providing to companies, whether it's as a UI specialist or backend specialist or DevOps, is automation of process. Okay, that's going to make this manual task, repetitive manual task, at one. Not only that, but you as a software engineer as well, you must, I wouldn't say should, you must also automate some of their process, your tedious process that allow you to not get, for example, the life that you want. In my particular case is the fitness, so I actually I want to automate some of the part of my life that give me this outcome, and of course it makes me feel much more better. Okay, so the emotion of feeling better and feeling great, the reason is not at the service of this emotion. So because of this emotion of feeling great and feeling better actually helped me to create all of this system and process, think about that, and of course enjoy the life while I'm and of course enjoying the life while doing this. Okay, that's also something that is the goal after all. But remember that most of the time the reason is at the service of the emotions. So based on that, for example, if you have something that is causing you trouble, if it's something that you don't know or you ignore or you don't have any practice, or it's something that is recurringly and you know how to do that, or is something, for example, in the coding, okay, if you see that this is this particular process of building the applications and then run your tests and then create an artifact is something that you do every single time you implement code, of course you want to automate that process. But again, because doing that is something that is tedious, it generates an emotion, that's why they create this. And I think this is, make a quick tangent here and then we're gonna go back. Any time that you have a feeling and that you want is to, for some reason, resolve, or that you see that is recurring in your life, okay, think about that and try to find a way to solve this. At least is something that is valuable for you, and which is something that is valuable when we deploy this particular code, when we use this kind of thing. So in any case, enough of philosophy, more now a hands approach, a more hands-on approach, which is what are the use case of this automations, the CI/CD and the continuous delivery, right? Especially using GitHub Actions. Well, two main cases according to Steve Keeney is that if your company have a SaaS and an open source, which is something that a lot of company eventually will going to produce. For example, eBay have Marco, this declarative way of creating user interface. PayPal has Amazon have this open search, which built by the community of engineering, and so on and so forth. I don't recall some of the open source PayPal. If you can help me here, if you not, doesn't matter. But the thing here is, you have a SaaS and an open source, The SaaS is on a private repo, the open source is on a public repo. So instead of you, anytime you want to bump up the version, the npm version of the open source, it will automatically bump up the version in the cloud, right? So you don't have actually to not only bump up the versions of the npm on this open source code and then on the npm registry, which is, hey, anytime you create that, let's go to create now a PR for that, so we can merge that to the masters, and there is a new PR. We need to do that and to create a new master, publish, and so on and so forth. This repetitive process. So this is quite interesting. Okay. Yep. This is quite interesting, especially for open source. All right, where they already have that in place. That seems quite interesting. Completely. And the other is that when you want to put labels, I don't know if well, building and testing pull requests. So anytime someone wants to contribute to the code, it's like, hey, we're going to build and test this. If those actually if those chains won't break the application and the tests pass, all right. So you don't have to do that manually locally. It's gonna do that on your PR, which is great. The other is that deploying your applications every time a release is created, and the other is that adding labels whenever a new issue is open. So these 4 use cases, right? The SaaS, the open source, as well as building and testing your pull requests, building and testing pull requests, deploying your applications every time it's released, and putting a label. Deploying your application deploying an application every time a new release, every time it's a release. Okay, every time a release is created. Okay, and the other is this is quite interesting. Okay, it makes a ton of sense. Okay, every time you put a release. Okay. Again, understand is now this particular use case is something that is going to provide a ton of values for companies, and you, of course, you're going to provide that ton of value to companies. Make a ton of sense. Okay. Not only for SaaS and open source to publish on npm, but also for building, testing PRs, automates or deploying your application every time you release, or a release is created, a label release is created, and adding a new label anytime a new issue is open. Okay. So we look at the GitHub Actions reference sheets. Okay, and some of the tips here when you're gonna create this workflow, which branches are used branches can be used wildcard to be filtered, and jobs are running in parallel. So here is when we're taking a look at the anatomy of this. You got it. So anatomy of GitHub Actions. Wait, what? Exactly. There you got it. Get started. That's right. But again, this is very narrow specific for this kind of company, right? So most of the time, the problem is for coordination. So the problem here is for coordination. Capitalism has proved that coordination, by putting incentive like that, we can collaborate, we can coordinate much more better. So in any case, so there is an incentive here to have coordinations. There is an incentive to have this dance. Pretty much when you go and dance salsa merengue, you know, especially when you or bachata, if you're gonna play that you're gonna dance with someone that is attract you, you have now an incentive to do that very well, and not only that, to exceed that. That's a good analogy here in the dance. That I definitely invite you to, if you have the time, to at least learn bachata, which is a very close dance. It's a very intimate dance between two people, a woman and a man, usually. But it is this intense, especially when you want to dance, when you want to, this is also go to our biology right now, is that when you want to dance with someone that is attractive, you definitely want to do that, you want to feel that feeling here, you're going to do everything to that dance, that coordinations happens, bro. You don't care how, but that will happen. And you're gonna make that happen. So pretty much like this, okay, this coordination of thing, and in this case, well, analyzing is the anatomy of the GitHub action, the CI/CD process, okay, again, which is the continuous integration, continuous delivery, continuous delivery and continuous deployment, and how is that particularly process, what is this anatomy here, right? Plan, code, build, they integrate that with build, test, and create an artifact that then is going to pass on to the continuous delivery, continuous deployments, continuous delivery, sorry. That is, once you have this artifact that is going to pass to this environment, to this staging environment, to be test as close as possible as the production, and if everything went well, you do that here. Again, once you do that, then you have to now operate on that, to monitoring that, and then repeat that dance, as you can see, right? So this is the so far the way of how now you can automate the process to provide quality products, especially for those big companies, right? Or for big company that you're gonna work at some point if you want to. So that's great, okay? So by understanding is this, you can not only provide its value to this, but also to companies, small companies as well. So hey, if they have, for example, a small e-commerce, or most of the time for small e-commerce, right? So hey, they have now this small e-commerce, and then you want to maintain and provide some new features and that kind of thing. So you have now is this thing in place. All right. So enough me of talking. All right. As a way to use these GitHub actions, we can is writing our workflows. So as they make what? Okay, GitHub action documentation automates, customize, and execute your software development workflow right in your repository with GitHub action. Exactly. Automates, customize, and execute your software development workflows right in your repository GitHub actions. So it is important to understand that these GitHub actions will gonna run on your GitHub repository to run the aforementioned things that I mentioned, right? So we need to know is what is this workflow And what is the anatomy of this workflow that allows to actually do that in GitHub? Okay. GitHub Action is a continuous integration, continuous delivery platform that allows you to automate build, test, and deployment pipelines, right? You can create workflow that build and test every pull request on your repo or deploy merge pull requests to production. This is the two commonality here. Going beyond that is something that perhaps you don't want, or deploy merge pull requests to production. So this is one of the things that this GitHub Actions allow. So as I mentioned before, useful use case for GitHub Action is that SaaS and open source to publish on npm, building and testing pull requests, deploy your application as I mentioned before, deploying your application every time a release is created, or in this case is deploy merge pull request to production or to a staging as well, and adding a new label whenever a new issue is open. So not only that, GitHub provides Linux, Windows, and macOS virtual machines, which is great. You can now actually use this to test your code. For example, your React Native application. There must be a chart for that. In any case, GitHub provides Linux, Windows, and macOS virtual machines to run your workflow. Or you can host your own self-hosted runners in your own data center or cloud infrastructure. So the component of the GitHub Actions, or the anatomy here, okay, GitHub Action anatomy, is workflow. Okay, it's a configurable automated process that will run one or more jobs. Exactly, like this. It can run one or more jobs. So it's a configurable automated process that will run one or more jobs. Workflows are defined by Helm. Let me actually do this. Okay. So this is now workflows. Okay, it's a configurable automated process. A workflow is exactly a configurable YAML file automated process, right? That will run one or more jobs, right? Exactly. A configurable YAML file automate a configurable or a YAML file configurable automated process that will run one or more jobs in your GitHub repo, right? In your GitHub repo. So workflows are defined in .github workflows, right? They are defined on .github/workflow, right? So this is now what it's going to look. All right. This is where you're going to define your workflow, this automated process, okay? And one of the things that, well, we actually is, we mentioned, right? So repo can have multiple workflow, each which can perform a different set of tasks, such as build and testing pull requests, deploying your application every time a release is created, adding a label whenever a new issue is open. So for example, we can reference a workflow with another workflow as a way to reusing that. Okay, so we can reuse workflows by referencing. So far so good. We also look at the main cases of GitHub Actions, which is great, and the workflow. And now let's take a look at the events. An event is a specified activity. It's a repository that triggers a workflow. Pretty much, right? You have now event. This is part of the anatomy. Okay, an event is specific activity that triggers the workflow run, and a specific activity that triggers a workflow. Okay. For example, an activity can originate from GitHub when someone creates a pull request. You can also trigger a workflow to run on a schedule by posting a REST API or manually. Interesting. So it can be triggered. Okay, it can be triggered by GitHub. GitHub, okay, specifically from Git. You can also trigger a workflow to run on a schedule. Okay, so for example, schedules. That's right, schedules. Or by posting to a REST API. Create a repo dispatch event, which means that repo owner repo dispatch. Code sample for creating a repository dispatch event. Fine-grained access token for create a repo dispatch event. This endpoint work with the following fine-grained token type. GitHub apps user access token. I don't follow. You can use these endpoints to trigger a webhook event called repository dispatch. When you want activity that happens outside of GitHub to trigger a GitHub Actions workflow. Okay, a GitHub webhook. You must configure your GitHub Actions workflow or GitHub app to run when the repository dispatch event occurs. So, OctoKit, your token, and then you define is this request, right? On post from this, then you want is to actually you say, hey, the owner, the repo, event type, on demand test, client payload. Fine-grained access token to create a repository dispatch event. But this is if you want to trigger a webhook event when you want activity to happen outside of GitHub to trigger GitHub Actions workflow or GitHub app webhook. Okay, so when you want to now trigger it's like the posting to a REST API, posting to a REST API. Jobs. A job is a set of steps in a workflow that executed on the same runner. So each step is either a shell script that will be executed, okay, or an action that will be run. But again, a job is a set of steps. Okay. So we have now the jobs. A set of steps that is executed on the same runner. Interesting. As a set of steps, okay, that is executed, yeah, a set of steps that is executed on the same runner. Two concepts here. What is a step and what is a runner? Each step is either a shell script that will be executed. Okay. So each, okay. So each step each step is either a shell script that will be executed, is either a shell script that will be executed, okay, or an action that will be run, or an action, another concept, or an action that will be run. Why this is important? Because you see, when you are creating this storytelling, we as humans are storytelling machines. We consume that and we make sense of the world through stories. The more aligned those stories are with the nature, the better off will be for us as a species. So exactly. Steps are executed in order and are depending on each other. Okay, interesting. Steps are executed in order. Okay. Steps are executing in order. All right. Steps are executed in order and are depending on each other. And are dependent on each other. Good. Since each step is executed on the same runner, you can share data from one step to another. Interesting. Since each step is running, is executed. Since each step is executed on the same runner, you can share data from one step to another. You can share data from one step to another because they're running in the same, because they're executing in the same runner, okay, or in the same process. Makes sense. You know, slowly things started to slowly make sense. Okay, you can share data from one step to another. Okay, for example, you can have a step that builds your applications followed by a step that detests the application that was built. You can configure a job dependency with other jobs, but by default job has dependency and run in parallel. By default jobs runs in parallel. You can define dependent jobs on each other. Okay, it's quite interesting. This is very, very interesting here. Okay. There you got it. Job has no dependency and run in parallel. Exactly. By default, jobs run in parallel with no dependent. You can define depend jobs on each other. For example, you might configure multiple build jobs for different architectures. Okay, without any job. For example, you might configure multiple build jobs for different architectures. without any job dependency and packages that depend on those builds. The build jobs run in parallel, and once they are complete successfully, the packing jobs run. Choosing what your workflow does. Using jobs in a workflow. Pre-reading building blocks in workflow. Add a script to your workflow. Controlling, storing, passing information between jobs. Using environments for deployment. Control the concurrency of workflow and job. Catching dependency to speed up. Storing and sharing data from a workflow. Create a matrix to define variation for each job. Okay. Again, the whole point of this is to see this huge overview of this anatomy. Okay. Action is a custom applicable application of the GitHub actions that perform a complex but frequently repeated task. You have now the actions, right? Then you have the actions. A custom GitHub action, or a custom GitHub action, or a custom app for GitHub actions. Yeah, a custom app for GitHub actions, platform that perform a complex but frequently repeated task. Performing a complex but repetitive task, right? But frequently repetitive task, right? Use actions to help reduce the amount of repetitive code that you write in your workflow file. An action can pull your Git repo, set up the correct tool chains for your build environment, or set up authentication to your cloud provider. So use cases, okay, is that pull your Git repo from GitHub, pull GitHub repo from GitHub, toolchain, set up a correct toolchain, set up a correct tool change to build your app for your build environment. Set up a correct tool change for your build environment, or set up an authentication to your cloud provider. Set up an authentication to your cloud provider. Going beyond the scope of this is at your own risk. That's all I'm gonna say. And then you got the runners. A runner, you can write your own actions here. And then you got the runners. Okay. And then you got the runners. Okay. A runner is a server that runs your workflow when they are triggered. A server that runs, exactly, it's a server that runs your workflow that run your workflow when they are triggered. That run your workflow when they are triggered. Each runner can run a simple job at a time. each runner can run just each runner can run a single job at a time, can run a single run or a single job at a time. GitHub provides Ubuntu, Linux, Microsoft, and macOS to run your workflows. Each workflow run execute in a fresh, newly provisioned virtual machines. Interesting. GitHub Actions, they're using is virtual machines. They're not using Docker. Interesting. They're not using Docker, they're using virtual machines. So each runner can run just a single job at a time. GitHub Actions provide Windows, Linux, and Mac OS. Alright. Or Mac runners to run your workflow. Or Mac runners to run your workflow. And they run and execute in a fresh, newly provisioned virtual machines. So each workflow is run in a fresh, newly provisioned virtual machine. Interesting. So because this runner, which is a server that runs your workflow, when they are triggered, and each runner can run one job, and each runner can just run, or can run just a single job at a time. GitHub Actions provide Windows, Linux, and environment runners, so you can run your workflow. In each workflow, it runs in a fresh, newly provisioned virtual machine. So that means that anytime you create is a particular workflow, right? Now the CI/CD process here, the GitHub Actions say, hey, let's go to assign this particular process workflow or process to one of our server in a virtual environment machines, newly provisioned, for each workflow, for any time you run is a workflow. So they must have. So the DevOps operation here is gigantic, bro. Gigantic, bro. Oh yeah, it is, bro. Oh yeah, it is, bro. Oh yeah, it is, bro. Mhm. 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 Okay, okay, that's quite interesting. That's very, very interesting. That's very, very interesting, by the way. Mhm. 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 Okay, that's quite interesting. That's very, very interesting. Okay, cool, cool. Mhm. That's very, very interesting, man. That's very, very, very interesting. Okay. Mm-hmm. So now that we know SD, okay, good, good, good. So now that we look at that, all right,
kind of push it up first. I even deleted just
this
like it will only
particular
work in that.
anatomy here, okay. So now that we look at the anatomy as a way to understand this, all right, that this GitHub Action Anatomy is made of the workflow, which is a jam configurable automated process that will run your that will run one or more jobs, and you define that it's inside of the GitHub workflow. You can reuse workflow by referencing them. You also have now events that will be get triggered that trigger it's an activity that trigger a workflow, and it can be done by GitHub or schedules or for posting but to a REST APIs, which means is that if you want to trigger this out from an outside source to trigger now a GitHub action, you can do that by webhooks. So you have the workflow, the events, the job, which is a set of a step that is executed on the same runner, on the same server that is provided to you by GitHub, that it triggers now the workflow. Okay, and each runner can just run a single job at a time. So what you do is that, because you have now a workflow, and in this workflow can have a set of steps, okay, or a set of jobs here that can have a set of jobs, and in these jobs is made of a set of a step that is executed on a runner, and this runner is a computer that is provided, or it's a server that is provided to you by GitHub, that only run is a single job at a time. GitHub provides you environments like Windows, Linux, or Mac OS. Whenever you want to run a workflow, so each workflow runs in a fresh, newly provisioned virtual machines. So these jobs that can be either a shell script that will be executed or an action that will be run, these steps are executed in order and they ping each other. But this is a bash script that is executed in order. And each step, or since each step is executed on the same runner, because this jobs runs is executed on the same runner, we can share now its data across different steps, and by default jobs are run in parallel and with no dependence. So this action thing that we mentioned is this GitHub app, okay, or this custom GitHub applications this custom GitHub application that do frequently repetitive tasks. So for example, okay, like pulling the repo from a GitHub, pulling the repo from a GitHub, set up a tool chains to build your environment. This is quite interesting. And by set up a tool chain for your environment, is that what are the things that we need to do as a way to make our application run. In other words, what is the build toolchains, which is, hey, let's going to define is in the case of Node, let's going to define is the environment that we need to do that we need to run Node, to have Node. And then perhaps other step that you can do along the way, which is setting up authentication with cloud providers. So let's say your application now communicate, which is something that you're gonna do a lot of the time, with third-party services, right? So you have now is for example, you're using is Google Analytics or logging error services like Sentry, all right? You are using some of the AWS to deploy your code, okay? You're using Twilio as a way to make this real-time communication happen. So you need a token from that. So this is quite interesting, and especially if you're able to describe this story, because now with that mindset, okay, we can actually is take a look at the code and make sense of that. Completely. And that's what we're going to focus right now, at least in this 10 minutes. All right. Okay. Okay. Good, bro. Good. 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 Oh my god, good. Yeah. Holy moly. All right. Okay. 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 So right now we are here. That's right. Because at the end of the day, we want to create this GitHub action. The way to do that is by saying, hey, I want to create now a folder here under this repo that will be hosted on GitHub. Great expectations. What French though? I think I did it. Let me remove in a recursive force way the GitHub. Why you're not? GitHub workflow, and do that, but is exactly. Is the GitHub repo. One easy way to do this is by fork that repo. Let me fork the repo. Fork GitHub. Okay. Yep. Fork the repo. There you got it. I want to work on this fork. Did I git branch action test actions? So if I say git switch to actions, you're gonna see all of this changed, right? Yep. You're gonna see all of this change here. The update test, as well as the exercise test. Okay. Okay. Cool. Yeah, it's okay. So because I'm pull this, I just want to do that for my own. So let me do something while here, because is fork this repo, right? Say, hey, I want to remove this, and I want to do this. First, I want to is, okay, let me actually close this. I want to now move to a reopen close editor. No, I want to move myself to a default location, which is this. There you got it. All right, good. Now please update my push. Great. And then I want to now remove in a recursive force way is the enterprise UI dev. That was quick. I want to now clone this from my repo. That's right. You say, hey, I'm cloning it. There you got it. Enterprise. Go. And now let's go to open here this project. Yeah, there you got it. All right, cool. So let me actually create now a new branch here. You could say, hey, git switch create. Okay. As a way to now create this new branch, which is action testing, right? Or action workflow. Right? That's right. And then I'm going to create the I'm going to create make there. That's one of the reasons I prefer to use now cursor, because it's going to autocomplete me all of that. Yeah. I prefer to use cursor for that. New text file, new window, please. That's right. Yeah, let's gonna use cursor instead of that. So good luck with Visual Studio Code. Take care. Bye bye. Close Windows. That's right. And we want to use now cursor here. Yep. All right. So let me open from the front master enterprise UI dev here. Open up here. Actually, let me change this so you can see what I'm doing. Enterprise UI development. Enterprise UI development here. That's not what I want. Cursor. Exactly, cursor. Yeah, much better. Okay, awesome. Here we are. Good, good. So this is a fork of Visual Studio Code. They're actually reinventing the wheel, right? So here we are, right? I just want to open up is here, and instead, all right, I want to make there the necessary files that GitHub will detect to run our workflow. This series of jobs that'll be triggered when that'll be triggered when one of the events, which is one of the activities defined by GitHub, happens. It can be by GitHub, it can be by schedule, or it can be by a webhook or third party, or posting to a REST API. Okay, and this events will trigger now is jobs, a series of steps that is executed. It's a series of steps that is executed on the same runner. So this series of steps that is a small that is either a small bash script or a shell script that will be executed, or in actions. So these steps are executed in order, one after the another, and are depending each other, which makes them great when you need to share data, because they are they're executed in the same runners. So these steps, okay, there is a series of bash, which is a series of shell script. Okay, this step, which is either a series of shell script, okay, or a actions that run is one after the other, since each step is executed on the same runner like this, you can share data across them, and these jobs are run in parallel by default, and they don't have any dependence. You can change that behavior if you want to. And this thing called actions is just custom applications in GitHub for repetitive, monotonous, tedious, frequently tasks. For example, pulling a repo to GitHub, or setting a build hold change. So for example, what are the things that you need or setting a build tool environments. So what is the environment that is needed to actually run your application? What are the dependency needed? In the case of Node, you say, hey, well, we need Node in this. We need Node, for example. We need Docker. Perhaps we need Docker and Node, like that. This is just a couple examples. Or when you want to set up the authorization for cloud providers, so whether it's analytics or or error loggers like Track.js or Sentry, that kind of thing. Okay, and because this job is a series of steps that are executed on the same runner, this runner is a server that runs one single job at a time. So GitHub provide you is a Windows or Mac or a Linux runner. Every time your workflow is run, it provide you a fresh, newly provisioned virtual machines. So your jobs are running in a virtual machines. It makes a lot of sense. There is a lot of layer of abstractions, but once you understand how do we get here, you will embrace the complexity. So it's this job that is running on a virtual machine, a newly fresh provisioned virtual machine that you can specify which virtual machine you want to run here, which virtual machine your applications or your jobs are going to run, and it specifies all of the build tool chains that you need to under these steps, which executed is this bash script, okay, which execute either a bash script or an action, which is a custom application in GitHub Actions to run repeated and frequently tasks. So for example, the GitHub clone a Git repo or set up a build tool environments. For example, in the case of Node, you say, hey, let's go to run now but because these jobs are running on a runner, and these runners provide you a new fresh execution, a new fresh virtual machines. They don't need to run Docker. It's actually running as a virtual machine. And the contrast between virtual machines and Docker is security, mainly security and research. And of course they're using virtual machine because they don't if a big company, let's say KPGM or McKinsey or any of these company, if each one of these company actually you want to preserve the security of this thing, that's why they provide you a virtual machine. Okay, that unlike a Docker that is run on top of your OS, the virtual machine is just something new generated from that. It's isolated completely from other virtual machines on that host. So again, this is something interesting to describe because this will again give you the narrative needed for understanding how you're going to define your Git work, how you're going to now define the build system needed to automate the process of to automate the build systems for maintainability here. And there's a lot of things going on. Okay, makes sense. Make a lot of sense. Okay, so now it is time for us to create this GitHub workflow under the GitHub here. We're gonna see that Interesting. It's not. It's not. I don't believe you. Do you need to refresh that? Oh, come on. No such. Okay. How you can create now? What? Nested folders with make dir command. What is the flag that we need to pass this? Okay. A parent directory. Okay. Okay. That's exactly what we want. Okay. Parent directory. That's interesting. So let me actually create now parent directories. And there you got it. We create now GitHub, where inside of this we're going to create our first workflow. Makes sense. In this case, the workflow we're gonna call is unit tests. Okay. So that's great. Let me actually remember that this workflow is a YAML file. It's just another markup language there. Yet another markup language here. Touch GitHub workflow name unit test .yaml file. Okay. And if you want to access to that, we can open is the unit test .yaml file. Great. And here we got. So we are going to define is this structure here. Okay. So you can define the name here. In this case, because I don't want to do this, I just want to now talk to I don't have that. What? Oh, interesting. Yeah. What you're using is this cloud, cursor small, GPT-3. This is all the models that you can use. Anthropic key, OpenAI key, Azure API key. Features. Chat always search the web. Fake chat stream default no context. Auto parse inline edit terminal hints. A powerful copilot replacement can suggest change across multiple lines. It is enabled. Copilot cursor predictor. Predict the next line cursor will move. 2 trigger after Copilot plus suggestion can be accepted using tab. So now I'm doing is this. Okay, or you can disable that. No, you can enable to say, hey, Copilot cursor prediction. That's right. And this is cursor settings. Beta, interpreted mode, long context chat beta, AI review, cursor help. Exact cursor help, show pane the hell with cursor is using, and that kind of thing. Okay, so of course, but here we move to the Why this shit doesn't change, bro? What the French toast? Okay. Is this one? Okay. Add to chat. So for example, here you can see is okay. Shift L to trigger the model. Okay, to trigger the model. And here you say, hey, please generate a test. Generate a base template please generate a base template. Yeah, please generate a base template. We're talking to all of this model. Interesting. Please generate a base template of please generate a base template of a test workflow of please exactly generate a test generate a unit test workflow that use the npm test from this project to be used in GitHub. So you're talking to the LLM say, hey, good, I'm going to generate the YAML file. That's right, based on your repo, okay? And then you say, hey, name trigger job steps, exactly the step which is this bash script that is doing. Okay, check out the code using the actions. Set up the nodes. As you can see, this now is using not only running this bash script, but is running the actions. This custom apps in GitHub that runs is repeated frequently monotonous task. Makes a lot of sense. And then it's using this build tool change, running this another actions as well for that. Install dependencies, and then you do is this. Let's go to apply those changes. Blah, and then you can now is to say, hey, the name of this will be is run unit test. So run unit test. Okay. Run unit test. You can say is accept those changes. Okay, and then push, but by the branches. Instead of you finding it like this, you can say is on push. I want to define is the branches as an array. You say main. Right now so anytime we make a PR, anytime there is a pull to the branch, all right, or anytime there is a push or a pull request to the main, okay, all right, we need to do this. This is this is the jobs that are to go. This is the jobs that is that runs a series of steps in a runner which is these servers provide to you by GitHub, where it runs your jobs. It runs one job at a time. Okay. In a new freshly virtual machine that it can be either Windows, Linux, or Mac. And here is when you're going to now specify is a series of steps. Okay. And this series of steps is just bash script or GitHub action, or GitHub actions. Okay, and then you say setup node, and then this one, action setup node with version 14. Set this to no version you are using. Yep. Action checkout version 3. Let's going to use the version 3 right now. Okay. You want to run this on the Ubuntu latest. They call this build and test as the name of this job. And test, right? This is the step here that we want to perform. Use a name setup node. But first is checkout. Okay. And then setup node. Here the using is version 3. Okay, which is good. We're not going to specify which version right now we're using. We should don't know which version they are using. Let's go to assume that they're which version they are using in the packages. And here is a version. No. Oh, that's great. They don't mention which version they're using. Good. Perhaps in the package log they're using. Log files package. Okay, they don't even mention which version. That's not a good sign. That's definitely not a good sign. Yeah, that's not a good sign. Anyway, you must specify the version that it must be run. Let's say that we want to run in the 20 version. Okay, this is the current version that we have right now. We say no version is 20. So okay. How can I move to there? Okay, good. 0.10, 0.0, right? Okay, cool. This is another step that I want to do, which is install dependency, npm ci, which is clean install. All right, and then run the units, which is npm test. So as a way to check if this actually is working as expected, okay, if we now take a look at the how do you put it, packages? No, the scripts. Okay, we are now running is this. Navigate to the example and run the test from there. This will fail. Navigate into the example and run the test. This will fail because we haven't defined is the test that we need to do, which is just do this, the test, right? We can say, hey, I want you to now run the binary files here, and that's it. That's one of the reasons why this build failed, right?
Thing is that Vitess out of the box Most CI/CD processes set a CI environment variable. If it is true, it will do it in run mode. If you don't trust that, you can also like choose to do a -- run. Cool. And so we will.
Okay. So now that we save this, as well as our file, now it is time to move to there, get the different here, get the status, the package JSON, and this workflow you define inside of this. Okay. All right. Cool. We already defined this. So this is supposed to work as expected. All right, without any issues. All right. And well, now it is time for us to say, hey, I want you to add all of these changes for me. Please do. Git status, right? I also want to add is whatever is on the GitHub, right? As a wildcard, it's a no matches found this. Git status. That's right. Now it Git actually go through all of this child and find them. Good. And we're going to now get a commit. Okay. We just say, hey, this is now the data. Unit test. Unit test workflow. Right. We commit the change. Oh my god. We commit the change, and then we push that to origin, which is by default our reference to the repo. It's a hey to push the current branch to and set the repo and to push the current branch and set up the remote upstream use git push set upstream origin action workflow. Oh, exactly, because I need to do is action workflow to have this automatically happen for branches without tracking upstream. See this. Yeah, but I just want is to only push, not the main is my new branch here. So if you click here, we can now actually go through this and say, hey, this is the unit test workflow. Let's see if this actually works as expected. Right? Like this, unit test workflow. Now what it's doing is GitHub detect that workflow under the GitHub, under this .github/workflow/unit test, and then it say, hey, you know what? All right, let me now that create a runner that I'm going to use to run this job based on this workflow. So if you take a look now here, okay, wait, what? Expected waiting for status to be reported. Wait, what? Oh. What the French toast? Some check hasn't been completed. Build and test expected waiting for status to be reported. Oh, it's because I'm pushing. Oh, I'm pushing is to the add branch. No, not at all. Ah, my god. No, close the pull request. No. Sorry. My bad. Come on. delete branch, bro. It's like that. It's like, what? I was trying to push that, but I don't want to push there, bro. I want to push is to the fork. Get origin. Get get remote. Get branch. Yeah, but what is this origin pointed? It's like get remote, get URL, origin. That's right. No, but I want to do that to my own code, not to that, bro. You know what I mean?
You can see it's the instant feedback here. It's true, it will do it in run mode. If you don't trust test this one.
Actions. Yeah, but what you actually git commit to? Git log, I mean. Holy moly. Okay.
Empty pull request comment, and then we'll open. We'll just kind of put, and we'll just kind of push it up.
How to push a PR to my own fork, because that is the perplexity. Go to the original repository in GitHub. If you clone the original repo before forking, let me actually add this fork for me, you know, because it's this one. So I want now to push, okay, push fork this branch action workflow. All right. So now if we visit this here, the pull request. But why is that? I don't want to make a PR on that, bro. It's on my branch here, bro. That's quite interesting. That's very, very interesting. Oh my god, it's this one. Exactly. It's this one. Because I want to do that to my own base code. Exactly. And create a pull request, but it's for this particular branch. Okay, makes sense. Makes sense. Makes sense. So yeah. Actually, if we take a look now at this unit test workflow, it is going to actually run that, but in my one, require approval for a specific review before merging. You can add this rule. Continuous integration has not been set up. Here, this branch has no conflict with base branch. Yeah, continuous integration has not been set up in this particular moment. Because we just only adding is this rule here. All right.
Very first, maybe. Github. I even deleted, just open up empty PRs if it's like update lint test. I'm like, what do you want me to say? I updated the lints, lint errors, like leave me alone. So you've run unit test. That seems familiar. Didn't I just make an action called run unit test?
Okay. Now, if we want to merge this change, okay, so for example, you say, hey, let's go to merge this change, merge the main with action, or in this case, is to say, hey, you say git switch to main, okay, say git merge main with action workflow. There you got it. Okay. Or you can is undo this. You can is undo this change. You can is undo. Okay. Okay. Okay, so git reset har to that commit. Har to that commit, right? You say, hey, to whatever is pointing to that. Exactly. Alright, so now what I want to do is to git switch to that actions workflow, and then from here say, hey, you know what, git merge. But that's interesting. It's like you define some sort of themes obscure thing that I don't even...
Yes, I did. You're learning some of my toxic is I don't like the empty and we'll open it, test. We'll just kind of push it up.
Oh, of course.
That unit test. We'll just kind of push it up. I'm only going to commit that unit test. We'll just kind of push it up. And then we'll open it up in here, and we can see that we've got a new branch with a PR. Add our very with that on the build system GitHub Act GitHub UI. I'm only going to up in here, and we can see that we've got a new branch with a PR. Add our very empty pull request comment. This is the bad part about being the boss, is I don't like the template, so I even deleted it. Just open up empty PRs. If it's like update lint test, I'm like, what do you want me to say? I updated the lints, lint errors. Like, leave me alone.
Because here we are just updating is this. Continuous integration has not been set up. This branch has no conflict with the bridge branch. Because here we don't have any other stuff running. Okay. So of course you say, hey, continuous integration has not been set up. GitHub Actions and several others can be automatically catch bugs and force style. Rule set ensure specific people approve pull requests before they merge, right? So you can add particular rules for that. Rule set, blah blah blah. We're not gonna dive deep into this. We're just going to say, hey, now we add is this, right? Good. We could finally add that to our own branch. Okay, and now when it's time to adding some change to that, all right, which is going to the content, no, going to the source, and inside of this Kanban board. Oh, it's because you, okay, this is an, okay, examples here, and on the great expectations bonus exercise like this. Okay, let me do this here. I already have some exercise here that I can change that. So for example, from here, this is just as a way to test this, right? For example, on the bonus exercise, but this is solutions, bonus exercise. I think the kind of test that we're running is URL the appropriate keyback case, which is in this case this one. All right. We can now is auto import this keyback. To keyback case, we import that. We can is locally run our test npm run. Right now you're not seeing what I'm doing, but what I'm doing is just to adding a modification here. That's all for this, right? We say npm test, right? And it say, hey, provide to install the following package. Sure. All right. Oh, because I haven't installed this dependency here. Okay, install of this dependency here as it is, and now we can actually run this test. And well, one of them is not passing. That's funny. Not that funny. And that leaf is where? You tell me which one of them is not passing? VTest user interface. Okay. You tell me which one of those actually not pass. Everything pass. Okay. Not sure why was the skip. Yeah. It's quite interesting. Actually, every test pass, but it say there is something here that is failing. That's quite interesting. It's a particular test that is failing, but it doesn't tell me which one. Oh, because it's a snapshot. Oh. Now it's running. Okay. No problem. There you got it. Okay, so all of this now is actually running and passing. So if we do this again, npm test locally, so all of these tests are going to pass, right? But say, wait, one fail. Oh, that's not good news.
Test. That seems familiar. Didn't I just make an act? Oh yeah, because in this repo running npm test had that error to make you go into a folder. That part about being the boss of action new branch with a PR.
So you're creating, you're running.
I really like the GitHub UI. It will only work in that PR until it merges into main. And this says cool. Gotta go up 2 levels, maybe 3. npm test. Fun fact, if you are talking and coding at the same time, if your npm test is npm test, again, cue some kind of exhibit meme. We'll do via test. There we go. npm test, and you can see it running through my test suite. Look at that. Oh, they...
Okay. Well, the only thing that changed is that we are now using is VTest. But it's saying now one fail. What the French toast is this, bro?
All pass, that's good. Now it goes into watch mode. One thing is that Vitess out of the box, environment, if you don't trust that, and so we will.
Oh my god. What is the failing test, bro? Where is the failing test and how to skip it? What is a failing test in this code base? when we run npm test. Okay. Command and how to skip it. Yeah, you're not helpful, bro. But yeah, it's not telling me here. There's something about this snapshot. Okay, there's something about this snapshot. To do, you know? Yeah, fuck that. Yeah. Like, and it's still failing that. What the fuck, man? Oh shit, but where is that test failing? You say one snapshot fail. One snapshot fail. One snapshot fail. Oh my French, those guys, bro. Jesus. Okay, how to skip snapshot testing in VTest. You can say skip. It's because when it's running this snapshot testing, it say fail or exclude snapshot in your testing configuration right now. Let me actually put this because it's causing me some troubles here. Test exclude for the moment. Exclude this. So when you run this, so please exclude the dim sum. Okay. Snapshot. Oh my French, those guys use environment variables for that. You can run your test with the environment variable set as this. Oh my, disable snapshot testing, man. Files by patterns, bro. Unless I delete this and then I run this. Oh my French toast guy, bro. There is a test that it say, hey, I'm failing. One snapshot fail. What the French toast guy, bro? Okay. Oh my French toast guy. But it's a pass waiting for files. Well, as you would say, is that what it is? Okay. Fine for you, bro. Okay. Cool. I hope it can pass. It's a pass waiting for file change. Well, anyway, okay, all right. Oh, it's actually passing, despite that it's actually throwing something snapshot failed. Let me see if this is actually going to work. So get status here, get status here. That's it. You say, hey, I just want to add now in the package JSON. What is the diff on the package JSON here? So get diff of the package JSON. No, please remove that change. It's like, what? Discard that change. No problem. We want is to say, hey, git add to all of this, git status here, git commit with a message. You say, hey, no, I don't want to actually even pass this. Okay, right. Is this adding a test? Okay, adding a test. Then you say git push origin, or in this case fork to actions workflow. There you got it. So if we want to say, hey, you know what? Exactly. So we add this, which is good. So anytime we want to create now a new branch, which is get exactly, we have already modified that. But for example, let's say someone is now contributing to this code bases and say, hey, git, you want to merge this. You want to merge this to the main. Say git merge. Say git switch to main. Say git actions. Git switch. Get action. You say, hey, get switch to actions workflow. You say get let's say get switch to, yeah, it's because I didn't merge those changes to that. That's what happened. I didn't merge those changes to that. I didn't commit that change to that. Git merge, git merge the action workflow with the main. In this case, the main with action workflow. I didn't add that change. Git main. Git switch to main. You say git merge main with action workflow. That's right. When you say git push origin here, that's a way to say, hey, I want you to now make those change to that, right? By creating a new branch, you say git switch a new branch, which let's call is feed unit test workflow. All right, so I get now push, which is git merge main here. Okay, and then you say git log on this branch is this. Say git push origin of this feed unit workflow, like that. Once we navigate to that, it say, hey, we got this. Let's go to compare that to the to this branch. Okay, and here we want is to not only add this particular change, adding tests. Okay, this is now, let's say, is have URL property here, add a URL property that title in key by case unit test, right? You create a pull request. It will automatically which supposed to check that. Okay. But wait a single moment. Okay, we are confusing ourselves vastly because okay. No, it's okay. Let me actually get switch to main. Let me remove that branch. Branch delete feed. That's right. Okay, I don't want you to push those changes to there. I know. What do you think you're doing? Oh, really? Oh my God. Okay, enough. Okay. Jesus. Git log. All right. Adding a test. Bonus exercise. And adding that. Okay. So I'm not sure. Okay. All right. So let me actually git push origin main to this. Git push fork in my case. It's git push fork to my main, right? Update were rejected because the remote contains word that you don't have locally. Okay, git pull fork main, right? You have diverse branch and need to specify how to reconcile them. Git log, and I want to be here. Okay. Git. I want to this hard reset. Do that commit. Okay. All right. Now we are here. I just want is to merge that branch, bro. You know what I mean? This to me the most what fucked up thing here, because I don't understand the process. It's okay. It's okay. It's okay. It's okay. It's okay. Okay. We got main, right? And we got the action workflow, and I just want is to merge that, but I want to merge that is inside of the Git, Git switch. How did you do that? And I don't know why exactly, and it's because you do a couple things here that was strange to me, especially here when you open this pull request.
You're right first, maybe. Github action. This is the bad part about
create unique YAML file, and then you merge that. Git merge branch actions to that. This is when you're starting to do this, right?
being the boss. Is I don't like the template, so I even deleted it. Just open up empty PRs. If it's like update lint test, I'm like, what do you want?
You know?
Commit the unit test.
Exactly. When you commit is the unit test,
We'll just kind of push it up.
push to the origin. Exactly. But that's what you did. And you did it blazing fast, but that makes sense. That makes sense.
And then we'll open it up in here, and we can see that we've got a new branch with a PR. Add our very, and then we'll open. Just do it. I really like the GitHub UI.
I really do like.
I'm only going to commit that unit test. We'll just kind of push it up.
Push branch, publish branch to GitHub, because it's doing some weird stuff behind the scene.
And then we'll open it up in here, and we can see that we've got a new branch with a PR. Add our very first GitHub. Bad part about being the.
And then it merged that action, and then he's merging that. That's the missing part. You in the actions workflow, you are here is merging that. You know what I mean? You are here actually merging that. Eventually here for this create is a git switch. Another brand we say actions. Okay, we say actions workflow test. Okay, where we already have this change. We already have this change here, and that is the unit testing here and the kind of things, right? And it is time for auth to say, hey, I want you to now merge, which is something that is using you did behind the scenes. Git merge the main with the action workflow. And I'm not sure why it merge branch actions. Okay. Git merge feature brand. Git checkout main, git pull origin. Okay. Git merge. That's quite fucked up. It's because he's using. It's because you are using. Is that UI, bro? It's because you're using his GitHub UI. Oh shit. Yeah, you know, it's like that's not good, bro. That's plain not. Anyway, bro. Anyway, you wanna play this game like that? Fine, bro. This is the kind of game you wanna play? Fine, bro. So now those merges were actually merged then. Okay. Okay. Okay, okay. No problem, no problem. But when we want to do this, which is to me quite weird because it's not running the particular CI/CD process, which you should, where you should run that. I already defined that. Okay. I already defined that. I already defined that. Okay. GitHub workflow. That's right. Perhaps the name of that man. Man, you're
first. And
GitHub workflow must be in plural, bro. Must be in plural, maybe. You know, workflows. So you can actually run this. Okay, GitHub Actions, Documentations, Overview, Writing Workflows. It's in plural, bro. Oh my French, those guys, bro. Oh my god. Oh, for fuck's sake, nigga. Anyway. Git status. Git add of GitHub workflows in plural, bro. Stop. Git status. Thank you. That's right. Okay. Git commit with a message to say, hey, fix typo. Jesus. Git push to this fork branch, and then the this particular branch action workflow test. All right. There you got it. Oh my god. That's right, action workflow test. So you can see now the change here. Fix typo, unit test workflow. It's something interesting because it is now we want to merge this to this branch here. And when we create the pull request, all right, is now we're able to see this. Right now you're not able to see this. It doesn't, no problem for that. Stop. As you can see now, we are finally looking at the proper output, which is a mixed typo. Okay, no problem. Okay. So run unit tests, build and test pull requests. We can take a look at the details, which is now because GitHub detect now the proper format. It say, hey, let me actually run this particular workflow, which is made of a series of steps here, okay, which is an automated process that you have now in a configuration file, YAML file, that allow you to run one or more multiple jobs that can be reused by linking the reference into other workflows. So this particular jobs, all right, that are now triggered based on an event or an activity that happened, whether it's a GitHub or a workflow or a posting to a REST API from different sources. Now these jobs, which runs, which is a series of steps that is executing in a runner, and a runner is a server that GitHub provide you that allows you to run jobs, and it's going to run a job at a time. It allows you to run one job at a time. Makes a lot of sense because it creates several processes by providing you a new freshly virtual machines, whether it's on Windows, Mac, or Linux. So all of this is something that when you define your steps inside of your job, which is a bash script or an action, which is a custom application from from the GitHub marketplace, to do some frequently repetitive tasks, now you can define those script or those set of steps most of the time for doing things like cloning the repo, or using Git to clone the repo, defining the build tool change for your applications, and that is what is the environment that is needed, as well as several series of steps that we need to perform a particularly automation process like build or test or static analysis, okay? And also when you want to define or set up an authorization with third-party or cloud providers. So all of this makes a ton of sense, but a ton of sense. Yeah, it is. Now once that is complete, okay, now we can see back to the pull request. Everything worked as expected, all right? All check has passed. You can see here, right? You define this particularly workflow to run. It worked as expected. You can also take a look at the details. So now it makes a ton of sense for that operating system running image. As you can see, they're providing you this particularly runner where it is giving you a new freshly giving you a fresh provisioned giving you a fresh, newly provisioned virtual machine per job. Okay, each runner can run a single job, or each server can run, or this process can run a single job, a single series of steps for exactly a single series of steps for or cloning your repo, or setting up build toolchains, or build your application, or for tests and that kind of thing. That's very, 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 very interesting as a way to be able to describe that. Okay, makes sense. Makes sense. Holy hell. Alright. Okay. That's actually quite interesting. That's actually quite interesting. And that'll be all for this video. Take care. Bye bye.